Hey, it says we're live, and we have good connectivity. Well, isn't that fancy? Hey, come here. I got a special guest today. Chuggy the Pug. Oh, yeah. Oh, yeah. See? Chuggy the Pug is here. Say hello to Chuggy the Pug. Is anybody here yet? Nobody's here yet, but Chuggy the Pug is here. Oh, yeah. Hey, look at this. Oh, is that food? Anyway, put him down. Hey guys, here's what we're going to do today. We are going to be talking about changing a quadratic equation from standard to vertex form. Okay? Standard to vertex form. So, I'll give you guys a second to start showing up. I know it's a little earlier than we thought. Hey David, how are you? How's things, David? You see Chuggy the Pug there? I'm kind of excited about today's lesson. I've got some prizes for you. We have a winner for who got this right, what this thing is right here. And, we'll show the shirt a few times, and it'll all be great. Hey, Vanessa, how are you? Come here, Chuggy. Come here. Oh, yeah. Oh, look what we got here. Look what we got today. We got a pug. Oh, yeah. We got a pug. He's a math pug. What are you doing? You're silly. Anyway, put him down. He's getting too hyper. Hey. Big dog's here, too. Oh, yeah. That's good, David. You saw the pug. Looks just like me, right? So, anyway, here's what we're going to do. I'm going to switch over to the document camera. Let's see if we can get this all set up and working nice and pretty over here. Here's what we're going to do today. We're going to be, we're talking about quadratic equations, right? Quadratic equations. And this is lesson number 3. And what we're going to do today is we're going to change from standard form to vertex form. That's what we're going to do. So standard form is, of course, ax squared plus bx plus c. And we're going to change that to vertex form, which is ax minus h squared plus k. And I did a video the other day that kind of talked about this, but it was kind of a review. And today we're going to be a little bit more focused. So we're going to only talk about cases today when a equals 1. So like, for example, x squared minus 4x plus 3. Let's say we want to change that to standard form. Or x squared plus 6x minus 1. Or x squared minus 3x plus 7. So we'll do those 3 right there. Now that kind of gives us a cover of absolutely all of the types of things that we're going to end up seeing, right? All right. So with that said, our winner for what this is, man, I was really surprised that none of you guys knew. Yesterday afternoon, there were a whole bunch of you here in the live feed, and nobody got it right. This is it's a replica of a Dundie Award, which is an award from the show The Office. And my daughter got this for me for Christmas a few years ago, and it says Dundie Award, Best Beard Award for Philip Brown. So that's me. That was kind of funny. And who got it right was Eddie Racine in second period. So what Eddie's going to win is not a roll of toilet paper. This is way too valuable. I'm not really sure what he's going to win yet, but maybe we should have an award today for one of you guys who gets a roll of toilet paper. Hey, if you're here, go ahead and just in the live chat say, hey, I'm here, because I can't see who's here, and I would like to know. I'd like to know who's here today. I'd like to see how you guys are doing. Get caught up on how your lives are going, what questions you're having with the math, and all that kind of stuff, all right? So, in the meantime, let's go ahead and get started with our lesson, right? So here's what we're going to do today. Once again, we're going to be changing from standard to vertex form. Standard forms like ax squared plus bx plus c, a, b, and c are coefficients. We're going to change that to standard form, which is a x minus h squared plus k. But we're only going to deal with the cases today. Hey, Alexa, how are you doing? We're only going to be dealing with the cases today where a equals 1. And that's it. So hold on, let me type something here in the chat room. All right, so let's get to this, shall we? We'll do this one first. This is the easiest one. Well, actually, before we even get to it, let's talk about what this is. Just this part right here. So let's go ahead and take a look at, we'll come back to this page in just a second. Let's take a look at this right here with vertex form. X minus h squared plus k. So I want to talk about what this part right here is with the square. That right there, that thing right there is a perfect square. It's factored. It's a perfect square that's been factored. Do you see? I know this is review for quite a few of you, but for a lot of you, that even though it's review, it's still a little tricky. It's still a little difficult. So this is one of the things, this is one of the key ideas that sometimes gets lost. And sometimes those key ideas, when they're lost, it makes it difficult to understand some of the procedures. So here's the moral of the story. Look, I want you to understand this detail, because this detail will help you to better understand some of the steps you're going to take. It might help you get a sense of what you're doing, and sometimes if you have a sense of what you're doing, the rest of it goes a lot easier. So knowing the spirit of the law sometimes helps you follow the letter of the law, meaning that you can understand why something is, and then you can adjust and you can be more efficient at what you do. All right, so let's do it, right? This one right here. This is a perfect square that's factored. So a perfect square is a number times itself, like 25, of course, right? 25 is 5 squared. So if you take a number and square it and you arrive at a new product, that is a perfect square. So those are for integers, right? For a binomial, let's say we had x plus 4 squared. Well, that's going to be x squared plus 16x, plus 8x plus 16. I was writing and talking slower than I was thinking. So 8x plus 16. Those two are equal, right? This is not x squared plus 16. Don't do that. Don't say that. That's bad, right? But the reason why we like perfect squares is because these are easy to factor. These are very easy to factor. And so we can take something like this and rewrite it like that. So that would be x plus 4 squared. Same thing, right? So another example would be x squared minus, let's say, 12x plus 36. That's a perfect square. Another example would be x squared plus, I don't know, 22x plus 121. You see, for perfect squares, the c term is positive. It doesn't really matter what the b term is. And here's the thing that's true. Here's the fact that's true about all perfect squares. For all perfect squares, we're talking about quadratics here, okay? Perfect squares. Is that okay? SQS for squares? So we're talking about for quadratics. Here's the deal. If you take half of b and you square it, that's going to equal c. So the one we had up here, half of b is 8. Half of 8 is 4. 4 times 4 is 16. You see? Yeah. Ah, hey, Madiana. You making breakfast today? So, half of b squared will be equal to c. So, like for this one right here, this one is actually x minus 6 squared. If you multiply x times 6, x minus 6 times itself, you get x squared minus 12x plus 36. And this one is x plus 11 squared. And do you see how b is negative 6 or negative 12? So if I take half of that and I square it, I get half of negative 12 is negative 6. Negative 6 squared is 36. Half of 11, or half of 22 is 11. 11 squared, 121. So that right there, this is what we're going to use when we start changing from standard form to vertex form. Good? You got it? All right, now we got a couple of other people in the room in attendance right now. So Mariana's here. She said she made quesadillas this morning. Uh, that's good. What kind of cheese did you use? And you missed it. If you were here just a few minutes ago, Mariana, it's not your fault. Um, we were supposed to do this a little later today, but uh, I have some meetings that I have to be in later today, so I won't be able to do the video live later. But you missed it. You missed it at the beginning of the video. We had a cameo appearance by Chuggy the Pug, so you missed seeing Chuggy the Pug. Sorry, man. Um, he's not in here right now, and I don't have any food to call him up here. But I wonder if I have anything in cellophane in here. I can get him to join us. Oh, because he is a chow hound. Well, this isn't really cellophane, but it does sound kind of plasticky. Sounds like food might be stored in here. Chuggy! Sit. Big dog's here too. Let's see if we can bait him up here. Good girl. Yeah. All right. No, we're not getting him. Well, maybe we'll get him in a little bit, Mariana. All right, let's get back on track now, shall we? Okay, so here's what we're going to do. We are going to be changing quadratic equations into perfect squares because that's going to help us write them in vertex form, right? So the way we're going to do that, take half of b squared and make that equal to c. So just to make sure we're good, do you guys know, let's say this was let's say a 16x. Do you guys know what number would have to go here to make that a perfect square? And what about if I gave you this? Would you know what has to go here? And then a tricky one. You know what goes there. So why don't you try those? See how you do. Ruben wants to know if he's late. I don't know. Why don't you guys try these? I'm going to talk to Ruben for just a second. Ruben, no, you're not late, but I'm surprised you didn't know what this is and you missed out. Man, you missed out because somebody already guessed it. And their prize is not a roll of toilet paper. This is way too valuable today. I don't know what their prize is going to be. But anyway, you're not late. I'm glad you're here. Hope you're having a good day. Let's see how we did on this over here. Ready? So if we take half of 16 and we square it, half of 16 is 8. 8 squared is 64, so it's going to be plus 64. Half of negative 2 is negative 1. Negative 1 squared is 1. And then this is the tricky one. This is going to be, check this out, negative 25 over 4. No, positive, sorry. It's going to be positive 25 over 4. So that would make all of these perfect squares. Now, what about if we had something like this? X squared, and let's say at the end it was 100. Or, let's say it was x squared, and the end it was, let's say 9 over 4. Could you guys figure out what numbers would have to go here and here to make those perfect squares? Yeah. Yeah. Let's see. So, try it. See how you do. Go ahead and give it a shot. You can just write it down in your notebook right there if you got it with you. And Ruben, you don't know what that is, huh? Well, it's from a TV show called The Office. This right here is from a TV show called The Office. It's they have this funny award show. It's supposed to be kind of like the Oscars for their office. It's called a Dundee Award. And my daughter had this made for me for Christmas a couple years ago. You can see what the award says right there. But yeah, that's all. So I thought you guys would know that, but I'm old. What do you know? All right, let's get back to this right here, shall we? If you said this was going to be a plus 10x, you're good to go. However, you could also say, if you wanted, you could say it would be not 10. I'm lying. You could say it's plus 20x, or you could say minus 20x, because half of 20 is 10. 10 squared is 100. Do you see? And so, if you wanted to figure that out, you have to figure out, well, half of what squared equals 100. You see? And you'd have to solve that. So you could solve that by taking the square root first and then multiplying both sides by 2, right? Like that. This one right here is very much trickier. This one is very much trickier. It's going to be either plus or minus 3 over 2, or just plus or minus 3x. Plus or minus 3x, not 3 over 2. Plus or minus 3x. That's all. That's all it is. Because if I take half of 3 is 3 over 2. If I square that, I get 9 over 4. So half of b squared equals c. In this case, that is another perfect square. Good to go? All right. All right. Ruben, you never seen The Office? Dude, come on now. You're making you're hurting my feelings. Here you are. We're suffering the apocalypse in isolation. You have Netflix. You've never seen The Office? Bruh. All right. So you should watch The Office. It's pretty good. First season, it's kind of weird. The whole show's kind of weird. First season kind of takes you a little while, but yeah, it's well worth it. It's one of the most popular shows of all time because it's really funny. It's well written. It's smart. Not everybody likes it, but maybe you will. Let's get to some examples now, right? So here's what we've learned so far. We've learned what a perfect square is, and we've learned that this is a perfect square. So vertex form has a perfect square in it. So what we've got to do is we need to change this into vertex form. And so what we got to do is we got to make this part. We have to use this part right here as a clue for what our perfect square is going to be. You see, if this wasn't a 3, well, this is not a perfect square because it's a 3. Half of negative 4 is negative 2. And if you square that, you get positive 4. This needs to be a positive 4. And it's not. So this is what it needs to be. So check this out. Here's how you do this. What you're going to do is you're going to rewrite it, and you're going to leave space, right? Rewrite it, leave space. What you're going to do is you're going to take half of negative 4, and you're going to add it. Half of negative 4 squared is 2. Do you see? Half of negative 4 squared is negative 2. Negative 2 squared is, of course, 4. But we don't want to square it here. You'll see why in just a few minutes. But what we do want to do is we want to make sure that this whole thing is equal to that. Because when we're done, we need standard form and vertex form to have exactly the same value. And right now they don't because I've added 4 to it. So in order to keep it equal, I also have to subtract 4. Yeah. And so over here we add it, over here we subtract it. Here we do not square, here we do. And the reason we don't square here is because our next step is going to be to factor. That's a perfect square. It's really easy to factor. And the thing is, that number is going to go right there every single time. Like if you did write plus 4, if you did go ahead and square it, you'd have to factor this, and it's going to be x minus 2 squared. You see that minus 2? It's a clue to what this is. And so on trickier ones like the last one we're going to do, that's going to be a big help. So there we square, and here we just combine like terms. Done and done. Now, there's some other ways we could go about getting that done. Maybe make it a little easier for this one. But this method I just showed you right here works for even the trickier ones. Whereas kind of just figuring it out, you might be able to figure this one out. You might be able to figure this one out. But you probably can't figure this one out. Like, here's how I could figure this one out right here. Like, I know x squared minus 4x plus 3. I know that plus 3 needs to be a plus 4, right? So I really need to add 1 to it. But if I add 1 to it, I have to subtract 1 as well because 1 minus 1 is 0. And this makes 4. So what I really have is x squared minus 4x plus 4 minus 1. And this is factorable. Oops, x minus 2 squared minus 1. Do you see? So you can figure that out kind of like that, but you don't always have to. All right. Now, well, you don't always have to. I mean, if you figure it out in your head and you got it, that's great, but it might be kind of difficult for this problem right here. All right, now, let's go ahead and let's do that one right here. X squared plus 6x minus 1. In fact, why don't you try it? You know, you're just sitting there at home. Why don't you grab a piece of paper and see if you can write this in vertex form? Go ahead. Give it a shot. Go ahead and give it a shot. See how you do. So who else is here? Let's see. Looks like we've got Vanessa and David, Alexa, Mariana, Ruben, but we've got more people watching right now. So I'm curious who else is here today. I don't know. Some of you guys might be a little shy, which is all right. It's okay to be shy. Um, let's see, David, if you're still in here, is this pretty easy to do? You think you got this? You feel comfortable? You feel confident? How about the rest of you? Do you feel like this is good? You got this answer? You got the answer for this one right here? You got this one answered? Here we go. We're going to do it. First thing you want to do, you guys can check your work. Just move that C term, right? You just move it, you leave space. This is definitely 100% the same as that. No problems whatsoever. Now, what we want to do is we want to make this part a perfect square. So we want to add a C value. Though that C value, to be a perfect square, that C value needs to be half of B squared. So half of B squared is that. Half of B is, B is 6, half of 6 is 3, so we got to square it. Since we added it there, we also need to subtract it here, right? So here we don't square it, here we do. The reason why is over here we're going to combine like terms, and over here we're just going to factor. So x plus, that number goes here every single time. And there you go, you're done. There we go. David says he's feeling good about this. That makes me happy, young man. That's good news. Hey, in Google Classroom today, I will upload some notes and an assignment. The assignment is assigned to all of the freshman students, whether you're in Cambridge or Algebra 1. For the Cambridge 2 students, this is just for review. So I know that you guys might have forgotten how to do some of these things. So this is good practice, good review for you guys. You can try the problems if you want. If you get stuck on them, you can ask me. We'll go over it. And if anybody has a question on what we did yesterday for your assignment, feel free to ask. You can just put your question there in the chat stream. All right, let's do the last one here, right? So let's see here. Transition over. Let's see, last one. X squared minus 3x más 7. Oh man, that's a tricky one right there. X squared plus minus 3x plus 7. So the reason why this one's tricky, Alexa says this is the earliest she's woken up. So Alexa, true story. I got an email from a student and an email from the student this morning, and the timestamp on the email was 4:38 a.m. 4:38 a.m. And they said in the email, "Hey, Mr. Brown, don't even worry about the timestamp." And then they had some questions for me. It cracked me up because they weren't just getting up for the day. Of course, they've been up all night. And oh man, Alexa, you're gonna have, not just you, a lot of you guys are gonna have some trouble when we go back to school. Speaking of going back to school, I have not heard anything else as to when we're going back. As of right now, it stands to be still April 10th. I think that's the right day, April 10th. But I really don't know. And we don't really know yet what's going to happen with how you guys are going to get grades, how finals work, any of that. The state education department has to figure all that out. They have canceled all of like the ACT, not ACT, sorry. They've canceled the Ames test, and they've canceled the AZ Merit 2. They've canceled all of those. It's up in the air what's going to be happening with Cambridge and with AP tests. I know you guys don't take AP tests yet, but all of that's up in the air, and we're still trying to figure out what's going to be happening there. So as soon as I know, I'll let you guys know. Man, coffee, 10 a.m. So Mariana wants to know what would happen if we don't go back to school. I don't know. We'll figure that out. Yeah, I'm not really sure. So I think it's kind of easy with you guys that are participating to show that you're still getting a learning experience while you're at home, because all of this is recorded and all of the interactions on Google Classroom and email, those are all recorded, so we can justify, hey, yes, you have been given and taken advantage of your learning opportunities, and those of you who are participating, you are getting good grades and passing anyway. So I don't think it's going to be too tricky of a thing for you guys. I think the perhaps where it's going to get confusing is the people that either had done really poorly, had been failing, or let's say you're a student that has, like, say, an 88 for the third quarter. What are you going to get for your fourth quarter grade? I don't know how we assign the grades. Um, yeah, I don't know. That's kind of a tricky thing to figure out. So we just have to wait for the guidance from the state as to what to do. Maybe we go back and we just count. I really don't know. If we go back on April 10th, that gives us about a month of school left. And maybe in that month we can collect enough grades. I really don't know. So we'll just have to be flexible and try to make the most of the opportunities that we have in front of us right now, right? Let's see. Ruben says, I heard that they were thinking about canceling school up until September, and he doesn't know if that's the case or not either. Yeah, I've heard those rumors too, and I don't know if that's true or not. Um, we'll wait and see. But in the meantime, let's go ahead and do our last problem here, and then we'll talk about these kind of housekeeping things, right? So our last problem right here, x squared minus 3x plus 7. So we're going to change this, which is standard form, right? Like if this was a function or an equation, it would look like that. We're going to change this into vertex form, ax minus h squared plus k, right? So we're going to change from standard to vertex form. And from vertex form, as you guys know, there's lots of really nice things that you have. For example, you can tell how many x-intercepts there are. All you got to do is look at the vertex and the direction. So like here, a is 1. So if this was an equation, a is 1, that means it's going to go up. The parabola is going to go up. It's going to look something like this. So it really depends, the number of x-intercepts really just depends on the location of this vertex. So this vertex is -3, -10. -3, -10, that's in the third quadrant. So this vertex is going to look something like that. -3, -10. It's going to be somewhere over there. So this is going to have 2 x-intercepts, no doubt about it. So that's one of the nice things that is offered to you from vertex form. You can just look and see the vertex. And so if you compare the location, the quadrant of the vertex with the sign of A, which tells you the direction, you can figure out how many x-intercepts there are. Boom, right there. Yeah, Alicia, you're not late. Alicia, you aren't late at all. Actually, this is the lesson for the freshmen, but I had to change some things around today because we have some meetings, and since we don't have like a bell schedule, the meetings get scheduled just like kind of whenever. So I know we're trying to set up a schedule and a routine, but we're not in charge. So some other people are kind of stepping in and saying, hey, we need to talk about some stuff this afternoon and things like that. So it's all right. We'll monitor and adjust. The nice thing about the live feed is it does get recorded, so you can watch it later at your leisure. You can make some popcorn if you want. And yeah. So no, you're not late. You're not late. Ours for the sophomores was supposed to start at 10, and we did this one right now instead. So let's get to the last one, shall we? Anyway, here's what we got. And this one's tricky because when you take half of 3, it's going to be a fraction. Do not, for the love of all that's good and holy, do not use a decimal. Look, you're still going to do the same thing here, right? And even though it's going to be a fraction, the arithmetic works out really pretty easy, because what you're going to do is we're going to add half of it here, squared, and we don't square it, but you see we kept the sign. And over here, we go ahead and subtract, and we square it. You see? So this right here is x minus 3 over 2 squared, and this right here, well, we got to get, there's a couple ways we can do this. This is 7, right? And this is 9 over 4. Well, that's -2 1/4. So we could subtract, and we could say that's 4 3/4, or we could change and get a common denominator. Say this is 28 over 4, which gives you 19 over 4, which is same thing. You could do it either way. It doesn't really matter. So that's how you change from standard to vertex form. And I will put the questions, the homework questions for this, in Google Classroom. And actually, I'll print a copy of it for you right here. It's just the last page, which is page number 4. So I'll put the notes and the problems in Google Classroom for you. And yeah, and then you'll be able to see them. So here, let me grab those off the printer real quick, and we'll be all right. So for the sophomores, we're going to start a live feed here in just a few minutes. That's just for you guys. And what we're going to be talking about today is functions. We're just going to review function notation, what a function is, and with a single input or a single output compared to each or paired up with each input, and some of the notation, composition of functions, all of that kind of stuff. So that's what we're going to do with you guys today. But to finish this one up, let's see here. To finish this one up, here are the first 5 questions that we're going to do. And I'll put this in the Google Classroom. So if you're a student of mine and you want to access this through Google Classroom, you can. So what you're going to do is you're going to change each of these into vertex form by completing the square. The instructions are very important, because you're not going to use the formula. You're going to complete the square to change this. And then the last question is right here. It says, ooh, this is tricky. So if you're a sophomore in here, I would suggest you try this last one right here. It says if x squared plus mx minus 5 equals this, which is x plus 3 squared minus n, find the values of m and n. That's a tricky question right there. That's tough. So, yeah, give that a shot. All right, ladies and gentlemen, boys and girls, that's day 3. For those of you who are Cambridge students, that was review, but it's a review of something I know that you guys kind of struggle with. I know that when A is 1, it's not so difficult. When A is not 1, it definitely gets trickier. If you're an Algebra 1 student, that's new. So give it a shot. Be patient with yourself, and please ask questions. If you don't know this, it's okay. It's hard to learn this way. We're trying to make the most of it. The only way we're going to do that is to, well, just try, be flexible, see what works and what doesn't work, do more of what works, do less of what doesn't work, right? So anyway, you guys I know are, right? Yeah. And we're going to have a contest later, and the grand prize for our contest is going to be this. This is worth a lot of money. All right. I'm gonna jump out of here in a few minutes. I'm gonna get myself organized. In a few minutes, we're gonna start on functions for you sophomores. All right. I'll see you guys in a bit.